Hello. I'm not quite ready yet, so sorry, bear with me 1 second. You know, as usual, I don't have my stuff together when I hit stream, but that's all right. We'll give everybody a minute to pile in. Hopefully, I normally don't stream at this time of day. Let's see, put a link on LinkedIn, put a link in Discord, and then start some sick music. So today, oh, this might not work. Yeah, too much words. The one from yesterday worked pretty good. There we go. This should be better. So today's topic is OS command injection. This is a topic I'm slightly familiar with. We took a peek at it yesterday. Essentially what we're doing here is finding some way to input shell commands, and the shell commands get passed directly to terminal and we're able to execute them. So let's dig in. In this section, we'll explain what OS command injection is, describe how vulnerabilities can be detected and exploited, spell out some useful commands and techniques for different operating systems, and summarize how to prevent OS command injection. So what is it, how do we do it, and how to fix it? And this looks like a very complex chart, but it's just a very detailed, simple chart, to be honest. So we have a hacker here who's making some request using curl. In their curl request, they are requesting a shell. So they must already have access to the terminal. So they already have remote command execution, or remote code execution is what it looks like. They're sending a curl to their hacking server to download this backdoor.shell file and then pass it to sh, the binary sh, which is similar to bash but not as robust. Well, to be honest, I'm not so sure that that's what's going on here. They might not already have RCE, but somehow they're able to send a curl command. Yeah, I guess we'll read more about this. But essentially, you know, this request gets sent to the web app. The web app processes the command directly from the terminal. It downloads the file from the web attacker's server and then runs it using sh binary. This allows full system control under whatever context they're running as. So this web application could be running as like a www data user if you're in Linux, or if you're on Windows, maybe like in or what do they use? IIS app pool or something like that. But whatever context the web app is running in, if you get a chance to do command injection, usually you'll end up running as that user. Or if there's like a separate library that's running that you're getting command injection from, you'll be running under the context of that, which sometimes could be root if it's configured improperly. So this allows you to access anything that you could access if you had terminal access. You can upload and download data, access to other servers that are on the internal network, or whatever servers this system has access to, edit security levels, admin application access, access sensitive data, and local network access. This isn't always the case. You may have to do some privilege escalation to get into like security levels and stuff. But I think, yeah, I don't know. I'm not going to speculate too much. That takes too much time. We could just skip ahead to the labs. I'm not going to do that. We're going to read about it quick. OS command injection, also known as shell injection, is a web security vulnerability that allows an attacker to execute arbitrary operating system commands on the server that is running an application, and typically fully compromise the application and all of its data. Very often, an attacker can leverage an OS command injection vulnerability to compromise other parts of the hosting infrastructure, exploiting trust relationships to pivot the attack to other systems within the organization. Executing arbitrary commands. Consider a shopping application that lets a user view whether an item is in stock in a particular store. This information is accessed via a URL like this. So we have our insecure website domain. We're on a stock status path. We're sending the product ID parameter with a product ID of 381, and then the store ID parameter with an ID of 29. So after the web app receives this, it takes the value of the store ID parameter and sends it directly to a Perl script. To provide the stock information, the application must query various legacy systems. For historical reasons, the functionality is implemented by calling out a shell command with the product and store IDs as arguments. This command outputs the stock status for a specified item, which is returned. Oh, it's passing both actually. So it's passing the product ID as well as the store ID as positional arguments, I think they're called. This command outputs, we read that part already. Since the application implements no defense against OS command injection, an attacker can submit the following input and execute an arbitrary command. So the input is and, which in Linux, this is how you can run another command. You can chain commands together doing this. Echo, which will repeat whatever follows it, which in this case is just some random string, and then another and. So it looks like in this case, this arbitrary input is being provided as the product ID. So instead of 381 here, we have this whole string. We still have the 29 at the end, and that's what you get down here. The arbitrary input followed by 29. So now we have this totally changes the way the command is going to work. We're still calling stock report Perl script, but now this is probably going to fail because it's expecting 2 positional arguments. We're not giving it those positional arguments. Instead, we're breaking away from this command and saying echo this. So now the terminal is going to echo this string, and then we're providing and 29, which probably this is not a binary. The first position in a Linux command needs to be either the name of a script or terminal command or some kind of alias. In this case, it's just 29, so unless the server is configured, this will probably fail to run. So we have a fail to run, echo this string, and fail to run. We're causing the terminal to do what we want it to do. The echo command simply causes the supplied string to be echoed in the output and is a useful way to test for some types of OS command injection. The and character, or I think it's also called the ampersand character, is a shell command separator. So what gets executed is actually 3 separate commands, one after another. So that's kind of just what I said. Yeah, exactly. This is what's going to happen. We don't have those positional arguments that are required, so our script is going to fail to run. We're going to echo our arbitrary output, and then also 29 is not a command. And then, you know, chances are if this output, well, not this output, but if the output of this command is just taken and pushed to the front end of our web application, it's not just this command. Chances are they're going to be grabbing whatever the result of this command is. So when we can run 3 different commands, the result is this. You're going to see this on the front end of the web application. And that's a way that we can verify or validate that we have command injection. 3 lines of output demonstrate that the original stock report command was executed without its expected arguments. This is what we just covered. Placing additional command separator after the injected command is generally useful because it separates the injected command from whatever follows the injection point. This reduces the likelihood that what follows will prevent the injection command from executing. So this is saying that we're adding, here was our input. So we're starting with an and, because that allows us to arbitrarily execute something. But then we're also finishing with an and because I suppose whatever follows it, it's kind of like commenting at the end of a SQL injection. We're normalizing whatever follows this, or allowing whatever follows this to run separately instead of diluting our command. Because if we try to run echo yada 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 29, it's going to echo yada 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 29. So it's not doing exactly what we want it to do. It's doing what we told it to do plus some. So we're causing it to drop this 29 off into a separate command or separate instance of terminal commands. Let's go ahead and give this one a shot. We'll get burp fired up, although we probably won't need it for this one, but why not? It's a good simple example to be able to use burp on. Alright, this lab contains an OS command injection vulnerability in the product stock checker. So we know the feature that's in scope, product stock checker. The application executes a shell command containing user supplied product and store IDs and returns the raw output from the command in its response. To solve this lab, execute who am I and determine the name of the user. So in this case, it's going to return the name of the user in which the web app is running as. So whatever commands we throw at it will run under the context of the user that we see in the who am I command. Let's just do some casual, we should probably turn proxy on. And then make sure intercept is turned off so that we don't get caught up. So here is what we're going to be, the feature that we're testing. Excuse me, all this burp suite's making me burp. We're going to be testing this check stock feature. So right now we see that the product page received a parameter of product ID 1. When we do this check stock, it's probably going to run a GET request that contains both this product ID parameter as well as a location or some kind that has this London as the value. So let's go ahead and turn intercept on so we can examine what's getting sent to the server. Maybe. Try that one more time. There we go. We have right here the two parameters. So this store ID 1 must be the ID of the London record. We're going to send this to repeater and play around with it a little bit. So in the past, I've noticed that the product ID is validated pretty well, so we probably won't be able to inject anything here. Oh, we can though. It's allowing it now. Unbound variable, who am I? Extra operand 1. So we'll do the and instead. 62. So that's not running the command. It's actually checking the stock. Because the and is getting used as a parameter separator. So let's do and, but then we'll URL encode it so that it doesn't get processed in the request, but hopefully it'll get decoded on its way and then run as a command. It did not. Unbound variable. Let's throw that and at the end as well. Because this store ID 1 at the end is running right after who am I. Yeah, that's probably what's happening. So we could actually probably use the semicolon as our separator. We just need to have two of them. Unbound variable 1 not found. No, I guess it's not running. Well, we'll just do it how the lab says to do it then. We'll say and who am I, and then we'll URL encode all the key characters. Convert to URL, URL encode key characters. Still not working. I wonder if it's getting reorganized. Let's move the payload to the other parameter. See if that works. There we go. So we got the username, which is this Peter-C588US. And then this would be the next step, probably, is to figure out what groups we're a part of and how much permissions we have. It looks like it's pretty secure and locked down. Hopefully I don't get in trouble. Nobody from Portswigger ever sees this and is like, Nate went out of scope. We're gonna get him. So we solved that challenge, and as I promised yesterday, I'm gonna do the crazy Russian hacker thing every time. Boom, is done. So let's move on to the next one. Oh no, I accidentally closed that and I didn't want to. 8:15. Yeah, we have time for one more, I think. As long as I don't close everything on accident again. We'll turn off the burp proxy. And we'll go to the portswigger.net. Yeah, we'll just go to the main page. Academy. And we were in command injection. We just got done with the first lab. So now we're going to learn some useful Linux commands. And I'm not sure. I guess if you're new to web app testing, maybe you skipped like network pen testing. Maybe you're not familiar with Linux yet. So it would probably be good to review this, I guess. I'm not going to read it though, because that's going to take too much time. These are useful commands. Whoami tells you what user is running. I guess it says it right here. And then we can get operating system information using uname-a. This also says the Windows. I did not know that. Is that true? I've been learning all kinds of new Windows commands lately. Oh, let's see. Ver? Really? Who knew? Not me. ifconfig for a list of our different network cards or assigned IP addresses. Same in Windows with ipconfig/all. netstat-an shows our network connections, allows us to see ports possibly. Same thing in Windows. psef, I usually use psaux, but same concept. ps is going to show you the running processes, and in Windows we can use task list. These are command prompt commands, but now most current Windows releases have PowerShell available, so you can possibly run PowerShell commands as well, and there are different PowerShell commands for each one of these, and then it kind of allows you to control the output a little bit more. And I guess Linux also has PowerShell in some cases. You can install PowerShell Core. I don't think it's very common for PowerShell to come on Linux, but if you learn PowerShell, you can use it on both platforms. Blind OS command injection vulnerabilities. Oh, blind. That means that we're not going to see the output, I think. Many instances of OS command injection are blind vulnerabilities. This means that the application does not return the output from the command within its HTTP response. Blind vulnerabilities can still be exploited, but different techniques are required. Consider a website that lets users submit feedback about the site. The user enters their email address in a feedback message. The server-side application then generates an email to the site administrator containing the feedback. To do this, it calls out the mail program with the submitted details. For example, mail-s. This is a great A from peternormaluser.net. The output from the mail command, if any, is not returned to the application's response, and so using the echo payload would not be effective. In this situation, you can use a variety of other techniques to detect and exploit a vulnerability. So I think what it's showing us here is the the web app logic. This is the command that's running from the web app, and this is the user provided input. So imagine if we were looking at code, it would say, you know, everything that's not highlighted here is going to be, well, I guess we would have to highlight this as well. Everything that's not highlighted would be part of the code. Everything that is highlighted is potentially input. So you think about a feedback form, it says message, and then what's your email address. In this case, message is going to be put here. What's your email address would be put here. And then the recipient of the email is hard-coded, as well as the rest of the non-highlighted stuff. So they're saying, in this case, putting an echo in here, although you may be able to cause it to work, you know, we're not expecting anything to be output. We're not going to take the output from this command and push it back to the front end of the web app. So if you did command injection here, you're not going to see it. If anything, the email that ends up going to feedback at vulnerable website would end up looking pretty weird. Or if we had an inkling of which binary is being used and the order of the parameters that are being provided, we could possibly change this up completely. You know, sending an email to ourselves, that would allow us to get around the blind limitation, right? We'll be able to receive output and it's going to get sent to us in an email. Detecting blind OS command injection using time delays. You can use an injection command that will trigger a time delay, allowing you to confirm that the command was executed based on the time that the application takes to respond. The ping command is an effective way to do this, as it lets you specify the number of ICMP packets to send and therefore the time taken for the command to run. Ping C. So this is an example payload. We're surrounding it with ampersands to isolate the command that we're trying to run and make sure that nothing else is interfering. The command we're running is ping-c. The -c is a count, and we're providing 10 as the count. So this is saying ping localhost 10 times. Localhost is yourself. So if the web server receives this, it's going to try to ping its loopback address 10 times, and that would cause however long a single ping takes times 10 as a time delay. That would be a way to confirm that you're able to inject commands. So let's see if we can do that. And then I think, yeah, I still need to get ready for the day. So after this one, I'm going to call it. I appreciate, it looks like I have 3 people watching right now, and it's out of my normal hours. I really appreciate you guys jumping on. Feel free to drop something in chat. If this is your first time watching, let me know, and I'll go through this whole spiel. If you found me through LinkedIn, I can plug some pretty cool things, but I'm not going to do that if you guys have already seen this. Access the lab. This lab contains blind OS command injection in the feedback function, so we know the scope of the function we're trying to test. Application executes a shell command containing the user supplied details. The output from the command is not returned in the response. To solve the lab, exploit the blind OS command injection vulnerability to cause a 10-second delay. Let's click on view details. Submit feedback, actually, that's what we want to do. Was that available here? Yeah, I should have just went to it from there. So we're going to be trying to cause this web application to pause for 10 seconds. It's said to use the ping command, but I don't know how reliable that is because it's not actually going to, you know, each ping may take less than a second. So I think what we'll want to use is something like sleep 5. Oh my gosh, and echo world. Echo hello, and sleep 5, echo world. Oh, that's not the command we want. I think maybe it's wait. Yeah. I just caused the process to go to sleep. What is going on here? Celery. I know there's a command that you can use in Linux to wait. Is it pause? Bash. Pause for 5 seconds. Tried pause, but it says syntax error, expected token. I don't know that that actually works. Oh, there we go. It is working. Okay. Maybe it was because I was using and. So it's not running concurrently. It's running, or not running synchronously, it's running asynchronously. It's allowing each one to be submitted as a separate process, and that's probably why we're getting all the process output. I wonder if this would allow it to run in order, cause it to wait. There we go. That's exactly what we wanted to do. We get hello, it waits for 5 seconds, and then world comes out. So we're going to use sleep, and we're going to be using semicolons instead of ampersands. So for a name, did it tell us which field to test? Feedback function, the application executes a shell command containing the user supplied details. The output from the command is not returned in the response. Exploit the blind OS command injection vulnerability to cause a 10-second delay. So that should be pretty easy. We could just spam like delay strings in each one. Sleep 10. Name, email. We'll just put it everywhere. That's going to make it sleep for 40 seconds though. Maybe that's not a good idea. Oh, burp's not even running. So we'll just put it in one spot. We'll put in a random email. Peter at portswigger.com. Subject, hey. Good morning. Drink plenty of coffee today. Oh, it didn't work. Name, Peter. We're gonna open up burp. This will be a little bit easier if we can just use repeater. Is that why they chose the username Peter? Because repeater? Maybe. Probably not. It's probably just a coincidence. They're probably just being funny with the whole Wiener Peter thing. Oh, the username is actually Wiener. The password is Peter. Proxy turned on, intercept turned on, and then we'll submit the form details. Peter, email, Peter at portswigger, subject, hey, drink coffee. Again. This time we'll catch it with intruder. Not intruder. We'll catch it with intercept. Too many I words. Oh my goodness, it didn't work. We're gonna have to type all that again. More coffee. So let's try it in the message instead. We'll send this to repeater first. And for our message, we'll say more coffee, sleep 10. That should be enough. And then we'll URL encode this. Convert URL, key characters. We didn't get a response. I don't know if that's good or bad. I guess what does a normal response look like? Let's get rid of that sleep part. Yeah, it looks the same. That didn't work then. I mean, is it expecting this and not working unless we use it? Or is it expecting us to do ping because that's how they did it? It's hard to say. This is where it might get kind of CTF-y. Convert URL, encode all characters. That might not work either. We just want to URL encode key characters. Still nothing. So if this is running in the same way that the other one was, we had mail and then some, what was it? Message. And then we had from, to, email, yeah. Web server. Maybe webmaster.email. So if we add something to the message, the mail command would fail. But we actually might have to close it with quotes first. That might be the part that we're missing. Because if we just add it right here, if it's part of our message, that mail command would fail. But then we could sleep for 10. And then we could probably get like a syntax error there or something. I mean, that should still cause this to run, but it would run in a separate process, and that's the weird part. So when I was running this in Bash, we needed to separate with semicolons to cause it to run concurrently. We could do double ampersand, but that might also spawn separate processes or separate threads. It's hard to say. I mean, I feel like this should just work. Because this first command will fail because of syntax errors, which I guess we didn't test that. Is that going to cause... Let's do like test. Is test an actual Linux command? Not a command. While. Yeah, so that still allows it to run. So this should work to do the semicolon. It's not pausing for 10 seconds though. Maybe we need to do it in the email spot. Hey, it's paused or sleeping or whatever. I think we did it. Could not save. Sweet. So let's turn off proxy and then we'll refresh the page. And boom, it's done. All right, you guys, that's going to be the last one for now. I hope to come back soon. I'm not sure. I might have some time to do this during the day today. But if not, I'll see you tonight or tomorrow. Thanks for watching. Have a good one.